Thank you for joining. We will be having this session with Gareth. We've done this, I think about 4 to 5 times now, which is pretty exciting. We've been doing this every almost every quarter just so we can learn from Gareth. Gareth is the CEO of Silicon Overdrive, and he's here with us today to share insights on containerization. So please take a moment to learn. Okay, it's not all the time that we'll be learning in the class, but we'll be learning outside the class today. And please try to mute yourself as we always do in the sessions. All right. And if you have any questions, please put them down in your notebook, and afterwards there will be a period where you can ask questions. Then you can feel free to ask them, and you can also put them up in the chat, and then they will be read out and answered as well. Thank you so much, and I'll hand over to Gareth now. Thank you, Gareth. Over to you.
Cool, thanks, Selena. And as always, thanks to yourself and Terence and stuff for the opportunity to chat and share some knowledge with your learners and stuff. For today, I have included one of my colleagues, the esteemed Zipporah, who will be co-presenting with me. So yeah, without further ado, I'll pass over to Zipporah.
Thank you, Gareth. Thank you, Selena and team. Good afternoon, everyone. So my name is Zipporah Wachira. I work as a solutions architect here in Silicon Overdrive. And one very interesting fact about me is that I'm actually an Azubi Africa alumni. So this really feels like coming back home for me. So very, very glad to have this opportunity to talk to you guys. And I hope this session is going to be super productive for you. Okay. We can start, Gareth, right?
Yeah, well.
Awesome. Give me a minute to just share my screen. Please confirm that you can see my screen.
Yep.
Awesome. Okay, so as Selena has mentioned, today we're just going to walk you through some basics of containers more from a practical perspective. So we are going to do a bit of an intro of what exactly containers are, some common platform. We're going to run through some application, and then what are some of the common challenges that in our experience we've seen in maintaining or in running containerized environments? What are some of the best practices that we've picked up along the way that would help to actually smoothen that journey? Any tips and tricks that we've also picked up? And based on the current industry right now, what are some of the patterns or some of the trends that we are seeing in terms of containers and containerization as a whole? Yeah, so that's basically the lineup for today. So to start with, I think the best place to start is really just what exactly the container is, or what exactly is that we call a container. And in very, very basic terms, essentially a container is just excuse me, it's just a self-contained, a minute. So it's just a self-contained environment for an application that is sort of pre-packaged with all the essentials of running that applications. And the essentials, by that I mean, think of the configuration files, think of any dependencies, think of any libraries that are required. So all of those items, all of those dependencies, all of those components, they're pre-packaged into a single computing unit. And essentially containers, they became quite popular due to the ability to actually allow developers to quickly create and deploy applications. And how they do this is that they essentially remove the errors that are associated with incompatibility between different systems. So if you think of the pre-container era, where developers used to do their development, maybe, for example, right now, if I want to develop an application, I'm going to use my local machine. My machine at the moment, this is it's a Windows laptop. It could be a Windows desktop. And then say now that application is ready to be deployed to production, and my production environment is maybe on the cloud, or it's an environment, a Linux environment. So there is a slight incompatibility between the two. And previously, this was quite a challenge, moving applications between different platforms or different systems. But now, by creating sort of this self-contained environment where an application has everything that it needs to run, it makes it easier to just move this one package from one system, one platform to another system, another platform. So that is really one of the biggest benefits of containers. Of course, there are more, but that is the big one. So a common analogy that you'll see being used to explain the concept of containers, and I do love this analogy quite a lot because it fits quite easily, is think of the shipping containers. I'm sure we've all seen this somewhere around. So the shipping containers. So if you look at this container here, think of what are its features, what are its characteristics, and then if you can identify those, you will be able to relate those to what are the key characteristics of a container, what makes a container container. And it is also from these characteristics that the key benefits of containers are actually derived. So first thing that we can see from this particular container is that it's an isolated and a self-contained environment. Essentially, what that means is whatever cargo is being transported within this single container, it's completely protected from any external elements, right? So it's a completely isolated and self-contained environment. First thing. The other thing is it's portable. So I can move this from the source. Let's say it's a car I'm importing. So it can initially be carried by a cargo plane, then moved into a ship, then carried by a truck. So it can move quite easily between different platforms without posing any sort of challenges. So it's a portable. It's essentially the container is portable. Second thing. Then the other thing we also notice is that most of this container, you'll notice they have very standard sizes. They are very specific in their sizes. And the reason for this is that to allow them to first easily be moved between different platforms, so they fit the dimension of whether it's the ship, whether it's the train, whether it's the truck. But also that standardization, it allows them to be easily stacked against each other, right? So in the same way, containers, the containers and container runtime environments, you'll find they're highly standardized, and it is this standardization that will actually allow them to be moved between different environments quite easily. Then, of course, if you have think you're wanting to import a large number of goods, it's as simple as getting more containers. If it's only a small number of items, then it's using lesser containers, maybe one, maybe two, depending on the size. So there is also an aspect of scalability that you can get from this. So essentially, what is this analogy, these same characteristics that you'll see in these shipping containers, they're the same things that apply to the containers that we use to run our applications. It's a self-contained and isolated environment, which makes it quite secure. It is very scalable. You can increase and decrease the number of containers for your application depending on, of course, your workload requirements, your traffic, your traffic and all that. If you have, say, very complex, if your application is quite complex, then you can stack multiple containers together, and then by layering them, then you have a full end-to-end application. By essentially break that down into individual components, place those individual components into their own containers, stack all those together, and you have a full application. And of course, as I mentioned, they are quite standardized. So you'll find most of these environments and also their runtimes. Think of your Docker, your Kubernetes, they have certain standards that they are there to, that allows them to be very compatible, easily compatible with different systems. So that's just a very easy and very basic way to think of containers and how they work and their features and the likes. So now we have quite a number of container platforms. Again, I'm sure you're familiar with at least one of these. Docker is the one that's most well known. But aside from that, you also have Kubernetes. You also then have other services that are now more cloud native. So for example, for AWS, you have the Elastic Container Service, you have the Elastic Kubernetes Service. And then for Google Cloud, you have the Google Kubernetes Engine. And then for Azure, you have the Azure Kubernetes Service. So the choice of these container platforms, of course, this is now one of the considerations, that's one of the things you have to think about when you're starting to work with containers. How do I know? Do I choose Docker? Do I go straight to Kubernetes? If I'm running on AWS, is it ECS? Is it EKS? So what exactly is it that I need to think about? What makes or what kind of application maybe is best suited for Kubernetes, best suited for Docker? When do you use what, essentially? And it's not so much a science, to put it, if I can put it that way, but there are some guidelines that you can start to think about when you're starting to, that you can start to think about in terms of choosing the correct platform to use. So for example, let's take Kubernetes, for example. So we know Kubernetes is an orchestration platform for containers, but Kubernetes, if you look at its applicability and its suitability, is when you have a highly distributed application. So this is an application that has requirements such as it needs to be very scalable. This is an application that needs to be very high available. So think of it like a mission critical kind of an application, but also an application that's borderline complex. Then that kind of an application, you would lean more towards Kubernetes and all the different flavors of Kubernetes, whether it's EKS, whether it's GKE, whether it's AKS. Then let's now think the other side. Let's say you're very new, just starting out testing containers. It's not so much that you're running a production kind of an application. You want to do some development, some testing. You have a simple application. You want to see how that's going to work. Then in that case, you'd be leaning more towards Docker. It's quite simple. It's quite basic. It's more the entry level platform, and the learning curve, even the learning curve for Docker is quite easy compared to some of the other platforms. So that kind of an application, simple, doesn't need too much orchestration, doesn't need to be too highly available, or doesn't have like stringent scalability requirements, then you would be thinking, you know what, let me go to Docker. Then now, when it comes to the service, the cloud native services, now, for example, for AWS, you have EKS and ECS. What's going to determine the choice between the two? So primarily, we can see, for one, both support microservices, so that's fine. But then there is also a very critical consideration here, which is whether you're running a stateful and a stateless application. So just to expound a bit more on that is, if you think stateful application, what that means is that this is essentially an application that's maintain some sort of session data. So think of things like databases or cache stores. So that's something that is stateful. That's something that needs to retain the session state. And then on the other side, think of maybe your web servers or things like a load balancer. So that one, it's not absolutely necessary to maintain session data or state data. So that would be a stateless application. So if you have a stateless application, then that's usually best suited for ECS. So it's key to note, for ECS specifically, it would not by default, it doesn't particularly support stateful application. There are ways around it by maybe utilizing some sort of external shared file storage or something of the sort. But if you have essentially a stateless application, then ECS would be the tool for you. If you have a stateful application, then EKS would be essentially the tool for you. But it's also key to note that for EKS, it actually does support both, because it does have provisions for persistent storage. So those are some of the considerations. There is also other things. I mean, of course, you also have to think about your team. Let's say it's a company. Where does your team's expertise lie, right? So you have to think, what tools are my developers familiar with? What services are they familiar with? And then select the solution or select a platform that aligns more with that. The decision could also be tied to a provider preference. So maybe you work a lot with AWS, then in that case, you may choose an AWS native services. Or if the rest of your infrastructure is in AWS, then it would make sense to run your application either or your containers or ACS or EKS. Alternatively, if your infrastructure is on Google, then it may not make a whole lot of sense to then go and run your containers on EKS. So it would make sense to use the Google service or the Azure service. So just some of the things that you can start to think about when you're thinking, which platform do I actually choose to do this for me or for this particular use case. Then another key one is, I think when you're starting out, when you're getting introduced to containers, or really just any technology, any new service, anything, one of the things that you always want to know is, okay, fine, I get the theory, I get the notes, but where does this actually apply? Where is this used in real life? Give me an actual example of how this is applied and how it functions in the real world. So with containers, in as much as we've said that there are some of those considerations that you need to make in terms of determining, is this a good fit for containerizing? So the good news is, I think at this point, containers have become quite popular. So it's very hard to say that it's only this type of application that you can containerize, or it's this type of application and not this. Really, it all sort of boils down to how you design your application. And this is where what we usually call a microservices kind of an architecture comes into play. So the way to think about this is this. Let's take even a very, very simple web application. So what are the typical components of a web application? So you might have a UI layer, which is what your end users are interacting with. You may have a logic layer, which is where your APIs are and all that. And then say you also have a caching layer between your API layer and your database, and then you have your database. So if you design your application such that each of these components or each of these functionalities, your UI, your API, your caching layer, your database layer, they operate as independent services, then essentially that makes it a microservices. And in that case, you can then go ahead and host each of these services in its own container. So it's the point I'm trying to make is that it boils down to design. However, you will see containers being used largely in certain industry just because the nature of the applications that are used in that kind of industry is more suited to a microservices kind of an architecture. So for example, if you think of the gaming platforms, right? So a gaming platform or a gaming application will have a whole lot of different components. But aside from having different components, it's also that this kind of application is going to have it's going to be characterized essentially by requirements such as needing very, very high concurrency, needing very, very quick scalability. It needs to be highly available. It has frequent updates. So if you break it down, and if you break down these requirements, you find that it's better suited to just have these components running independently as their own services, as opposed to designing a single monolith, as opposed to designing like the application as a single monolith. So these are some of the common applications. It's not an exhaustive list. It barely covers the list. So just think of it as if you can break down your application into individual services, into independent services, that creates a microservice. And if you have a microservice, then you can run that in a container. Okay, so I'm going to now hand over to Gareth to just run over the rest of the presentation.
Thanks, Zippy. I think I will then just take over and share screen. Then it just makes life a bit easier. Cool. Thanks, Zippy. Let me quickly pop that back over. There's my screen sharing. Cool. Okay, cool. So just to maybe just expound on some of the business cases and stuff that Zippy was also speaking to, what you'll often find is a lot of companies have even written their own orchestration. I believe Netflix went through a couple of iterations of their product where they actually kind of created their own ability to scale up and scale down the pods and the stuff to handle people streaming and things like that. So, a lot of these things have really evolved over time. With the workload, so that it really can become something that gives you a competitive advantage and stuff. So what are some of the considerations as to where to run. Do you run containers? How do you run it? And all those sort of things. So a lot of the time you want to understand things like the security, the image, the runtime, what is the network. So, as you've seen, a lot of the things have the ability to run at either Azure or... Is that my side that's echoing, or is that somebody else? Can you guys hear that as well? Okay. It just sounds like they might be there. Cool. So basically, yes, you've got, so Kubernetes itself is native to Google, and then obviously you've got the EKS, which is the wrapped offering on AWS. You've got Azure's offering, and you've got a lot of other ways to do the containers and things like that. So it's really about trying to just understand what you're trying to do and how to do it. Then within Kubernetes, you get things like namespaces, and then how do you segment it so that you maybe want to then do a bit more within your workload. And maybe you want one Kubernetes, but divided into multiple namespaces, or maybe you just want a container and you want to still run a monolith, but keep it within that container. There's a lot of different ways and advantages to certain things. So it's really just trying to understand, how is your workload going to scale over time? How are your developers going to be interacting with it? What's going to make life easy for you or your colleague or your other developer to be able to work on features, to be able to push things out whilst not bottlenecking each other, but being able to run easily. So a lot of the time, you really just want to understand how the complex orchestration is going to work, how your networking is going to work, what is the end goal. What we often see as consulting partners is a lot of the time clients might have something and they need a bit more understanding, or what they've done is they've maybe outgrown their current architecture, and therefore they either want to move to containers to make life easy because maybe they've got certain challenges based on their current thing, or they need to maybe change the way or way some of their containers are segmented, or way some of the things work, to make it easier for them to split out some of the services and to kind of create more of a microservice or a support container role, or move some things out into scheduled tasks and stuff. So again, containers make that relatively straightforward. And then it's useful to understand what runs inside or outside the container. Now, what does that mean? And we'll come to that on one of the later things, but it's important to understand that, as Zippy said, what the container does is it's basically a self-contained environment that deploys. But in reality, if you're running it on a web server, instead of you needing X or Y installed on the VM, you can now install it within the container and you can ship it, but you still need to be aware then. So let's say, for instance, you're doing a standard LAMP stack. So you're running Linux, Apache, MySQL, PHP. You then still need to be updating the Linux and your security of your base VM. You also need to be then updating your PHP and your code running within the Docker and any other dependencies within the container. So you need to know what's running inside and outside, what can be shared services, and more importantly, that you just kind of have a good sense of minimalistic concepts and what can be used and why would it be used, so that you really just kind of are going into containers with a lot more of a structured understanding of it. Then similarly, you get logging. So one of the other things that we often see is, particularly on AWS, people will use logging, or they don't log anything that happens in, say, EKS, or once something goes into the container, they can tell you what happened at the hypervisor level or at the VM level, but they can't necessarily tell you what's happening within the container. Or maybe they've only got logging of the application within the container and not of the hypervisor. So you've also got to understand, if you're installing something like CloudWatch, or if you're installing something like Grafana or Prometheus, to be able to do it, what are you wanting to track? What is important to you as the developer? Are you tracking more on the infrastructure side, more on the application side? And then where are you storing those logs? Are you pushing it to another pod in the cluster? Are you pushing it outside of the cluster? Are you storing it to an external source? Those are all the things that you kind of also just want to just make sure that you're understanding it from an architectural perspective from that. And then lastly, the consideration that is going to come up on one or two of the other slides as well is organizational resistance. And by that, we often see that if people have got certain tech stacks and certain things, there's generally a certain understanding within the team. And a lot of them, they're resistant to change, whether that's a case of people are scared of change, or they just don't understand, or it just takes a bit of time to understand how containers work, how to update it, how to then push updates through. How do you connect in? How do you see the routing tables within a cluster? It's not the sort of thing that all developers want to do. Some developers would rather just focus on the front end or the back end. They don't always want to know what happens under the hood and how the goodies work underneath it and stuff. So sometimes you find that there is resistance from developers or people within the team to change, and particularly to something around containers. So it's always good to make sure that decisions made are able to be supported and beneficial. You don't want situations where one person leaves a team and nobody else can facilitate or cover all of those aspects. Common challenges with containerizations, and this is obviously a non-exhaustive list, but things like doing horizontal scaling. In other words, let's say, for instance, again, we've got a simple, web service or application service. So maybe you've got traffic routed in. And the traffic comes in and it hits the front end. Maybe that's written in React or something like that, and that sits on a pod. And then that maybe is then calling another pod or another container where it passes through the API traffic. And then maybe when your website gets busy, you then create a second or a third pod that basically handles the API to handle the loads. And then maybe you have a separate container that maybe handles your Redis or your database or your caching, or maybe logging or things like that. So maybe you end up with 5 or 6 or 7 containers in your workload. So being able to scale out horizontally is easy. Generally, all of the orchestration engines handle that pretty straightforward. You just need to set up the certain conditions for them to scale out, and it works fine. Vertical scaling is increasing the amount of resources for a pod, and that often can be more challenging, and it can often take time to either deploy or to spin up the second one, or there's certain other things which sometimes that trips people up and their teams up. Also then looking at things like long Docker image build duration. So again, that speaks to trying to make sure that your image sizes are as small as possible, that you're not putting unnecessary things in. And more importantly, if your workload does have 5 or 15 containers, if you're pushing an update or you're trying to push through 5 updates a day, is it taking a few minutes to deploy? Is it taking 5 minutes per container to deploy? Because that obviously will impact your code pipelines and your things like that. The other sort of things that you often will see issues with at some point is nodes failing to join a cluster, pods stuck in pending state, general kind of things that just, it's harder. You can't just SSH onto the box, or you can't just kind of do certain things. You often need to go in through like kubectl for Kubernetes and things like that. So generally we find that Kubernetes is a lot more effort for teams to get to than something like just running a Docker container on an EC2 on AWS or on ECS on Fargate or something like that. So generally running a full Kubernetes thing generally requires a bit more skills. And then often there is that skills gap in terms of really understanding a lot of those sort of things. So maybe a real world illustration. When I first kind of got involved a lot with the EKS and the stuff was many years ago, and we had a client with a particular peculiarity and stuff. So I chatted to a few people, and every one of them gave me completely different recommendations. When I asked the one, well, this person said this, they said, I haven't even heard of that tool. And you're like, okay. And that's when you start realizing that a lot of these things, take time, they take skills. There's a lot of stuff there, and there's a lot of ways to solve it. But it doesn't always mean that just because somebody says they're an expert, they're going to be able to jump into your team and hit the ground running. You might have certain ways of doing things or certain skills or tools that maybe they're not familiar with. They might understand the concepts, they might be able to pick it up quicker than somebody who's not, but just again, be aware that with a lot of these things, there's so many tools and ways of doing it that have evolved over the years that it's not as straightforward as just saying, Angular is Angular or PHP is PHP. It's not always quite as straightforward with containers and a lot of those things. So from our side, best practices for containers, and again, this is not an exhaustive list, but one of the things that we see a lot of people ignore is security. From our side as a partner, we always try and position security first, as does AWS and all of the other cloud people. We would then normally recommend using hardened images. In other words, your operating system is hardened, generally according to CIS standard benchmarks is the one we normally use. Use verified images. We've seen clients deploy things from script, which deploys your containers or your various goodies, only to find out later those images had been compromised or there'd been some other backdoor put on or something like that. So if you're not getting your images from a trusted source, it's no different from anything else. You wouldn't go and install a Python library or whatever from some random site on the internet. You want to kind of pull it from a trusted source of the repo, and you want to make sure that just because something's a Docker image, you're not kind of forgetting common sense and bypassing those things. Similarly, you also want to be aware that there are tools for doing things like image vulnerability scans, as well as scans on your code, as well as looking at things for like CVEs or patches for your operating systems. There's also tools to do vulnerability scans for your Docker images and stuff like that. Again, with security, we would always recommend running your containers in your private subnets with a shared load balancer in the public subnet to front the traffic through, so that generally you're only exposing port 443. There's very seldom a real need to run your compute in a public. Sometimes there is, but for the most part, you want to kind of do that because, again, it's a lot more effort to maintain, and generally then you want to try and make sure that your containers are able to manage themselves and the communication within, because you'll often find that people run very small pods for Kubernetes or ECS, and they generally will often have like half a CPU or one CPU for certain things, and they'll generally have a short lifespan. So they don't generally want to have a lot of overheads on it. So generally you want to try and make sure that those are private as much as possible, because people do sometimes tend towards, trusting the security at the perimeter of the things of the cluster rather than within it. So that's also where we try and make sure that people are aware of security at all levels, and make sure that they're taking as practical approaches as can be. Similarly, again, ensure strict security group roles. If you're spinning up a service, or if you've got a backend, set it to only allow traffic from your front end. It shouldn't need to be able to accept traffic from any other IP range, So just again, because it's a container, it shouldn't mean that you're bypassing the normal sort of security restrictions that you would be putting in if it was on a vanilla EC2 or some other sort of thing. Similarly, try and always move your secrets out from your containers. You generally never want code containing anything sensitive. You want to always try and use something like parameter store, secrets manager, or secret stores within containers. A lot of these things have their own ways of trying to do it. But in essence, what you're really trying to do is create an environment where your secrets and your database credentials and all that sort of stuff can be rotated seamlessly in the back end. Your developer never even needs to know when it's changed. The key simply writes the code, deploys the code will pick up the secret that is valid as of today, and it will connect and be able to do what it's meant to be doing. It doesn't need to know anything else. The developer doesn't need to know what's happening there. So that's something, again, that within the containers, you want to make sure that you are implementing that. And as I said, again, you need to know what is being stored within the container and without the container, and make sure that there's nothing sensitive or whatever, that if something did get accessed, then it would be a problem. Keep container compute requests to a minimum. So again, be aware of what can be shared, how it can be shared, and how you can try and structure it so that it's trying to do as minimal as it can, because that in essence will A, mean it runs faster, and B, means it saves you cost. It also means that you can run things in a better kind of microservice environment to really kind of just keep things optimal for that. And that in turn just talks to Docker size images, and there are ways around that. And then run antivirus. Just be aware there are products from a lot of the antivirus companies that are specific. So we normally use a vendor called Trend Antivirus, and they actually have a product specifically called Container Security, which is a very, very lightweight footprint, just specifically designed to be running in containers that maybe are only using half a CPU or one CPU, so that they don't stress the compute on that specific thing. Generally, if you're running containers on an EC2, there's different products for that, and there's a much wider range of products that are fit for specific purposes than maybe what there was 4 years ago. Tips and tricks. Implement horizontal auto-scaling. Understand, same as with your normal sort of EC2s and stuff, if you're normally running stuff, or even Lambdas, understand what your base size is that you need for your application to run. If that 1 CPU, 2 CPUs, what does that need to be for it to tick over? And then rather implement scaling rules or wait for it to grow, so that maybe when you're busy during the day, you've got 10, 15 containers, and then at night, or when your thing's not so busy, it scales back into 4, 6, or however many you want in your things, so that you're really trying to look at seeing how you can save costs and stuff like that. Implement health check endpoints in applications. Again, try and create control points or gateways, so that as the data passes through, you can then debug things easier and log it and stuff. So this again would be what Zippy kind of mentioned in terms of like stateful versus stateless. So generally in a stateless application, you're simply passing the data through. There's normally an API, there's a simple pass through of data, and then a return of the data. But what are the health checks of that thing, of that server, or those points, in case there are issues later that you need to jump into? Maybe your database is spiking. What is actually the cause? Is it too many calls? Is there this? Is it that? Make sure you've got enough sort of health checks in place to make it practical for you to debug and understand, if there are issues. Optimize your Docker build durations by creating custom base images with cached modules and pre-installed tools. This is obviously one of those things that requires a bit of in-depth knowledge of your workload, and therefore you need to know what you're doing, what can be cached or pre-installed with certain tools, so that if there's an update of X, then you maybe need to spend a bit of time and just reinstall your things on, create a golden AMI or another things, update your launch configuration, and away you go. But it will mean that then your build durations can be smaller, they deploy faster, and generally then it's more fit for purpose. So again, you want to just understand where you can kind of leverage a lot of the benefits of reusable services within your Docker containers. As always, monitor and optimize your resource usage. That's using things like maybe CloudWatch or various other things. But again, if you don't keep an eye on it, you'll never know if you've over-provisioned things or if your stuff is running slow and sluggish and giving users a bad experience. Automate cluster management, where possible. If you are going Kubernetes or ECS, there's a lot of these sort of things that are starting to come out. AWS has made a lot of advantages. There's a lot of things that can be there, and it takes a lot of the load for how these things get deployed. What are the rules? How does it scale? You don't want to be doing that manually. It's really not worth anybody's time and effort. You just need to make sure that you're keeping an eye on the rules and making sure it's doing what you think it's doing. Similarly, if you are fanning out and doing horizontal scaling, look at using spot instances. It's less than half the price. You keep your core workload on demand or your normal things. But spot instances, particularly if it's maybe scheduled tasks or maybe things that are increasing, they generally aren't going to need to be there for long-lived. So spot instances can be a great way to save costs for a lot of types of workloads. And then, as I said, review and optimize regularly. It's always what you want to do. And then from our side, from dealing with a lot of clients over the years, we've seen a lot of people create the microservices, going to namespaces, do it into things. Battens and Lambda and serverless is certainly where you start seeing a lot of the moves towards trying to eliminate the need for their team to manage certain things. And it is one of those key things. So from my side, I would always say, look at the cost of running a container on an EC2, on ECS, and then if you're running it on ECS, run it on ECS or on EC2 or Fargate. Fargate means you don't need to patch the underlying operating system. It can leverage the AWS managed services and therefore takes a load off you and your team. Similarly, if you are doing other things, what other AWS services can you maybe integrate with? So for instance, let's say you've got a caching layer. Do you run Redis on a pod in your cluster, or do you kind of have Redis on the same web server container, or do you maybe leverage Elastic Cache and take that outside of the container? So there's a lot of sort of services that if you were normally running it on an EC2 or Lambda, there might be other services from AWS that you could use. A lot of these still apply. You can run them within your cluster, but you don't need to. So you want to just understand that. Okay, let's give you another example. Let's say I've got traffic coming in, hitting my web service, and I don't know, but there could be massive spikes in traffic. So I get advised that we should rather implement a queuing mechanism to make sure that the server can't get overloaded. So I say, okay, cool. How do we want to do this? And the considerations come back and the team says, hey, we're very comfortable with, say, RabbitMQ, and we want to run Rabbit. Cool. How do we want to run Rabbit? Okay. So let's pop Rabbit on a separate pod or a separate container, and we'll leave it in the same ECS. Okay. Now, what happens if that pod doesn't work? What happens if it's restarting? Oh, okay. Well, Rabbit supports a cluster. Okay, how does that work? Okay, well, now we need 3 pods running Rabbit because we need 3 to run a cluster efficiently. So now we're running 3 pods to do a thing, and you kind of start getting to a point where you're like, how much time are you spending making sure that there's reliability in components that the end customer doesn't care about? They assume if there's a queuing mechanism, it works. They don't really care how you're doing it. It's invisible to them. In which case, would something like using Amazon's SQS method just be simpler? And, obviously there's a cost per million SQS messages and stuff, but then it suddenly saves you running a three container Rabbit cluster and then configuring it and making sure that it's orchestrated and always up and all the rest of it. So those are sort of things where you just want to understand how we kind of make sure that the developers are building things that are efficient, adding features to the end customer. And maybe in time you say, hey, maybe if we get 1,000 customers, then we want to maybe look at bringing up the Rabbit. But until we've got a product that's working, we've got clients paying, and we've got a certain thing, it's not worth the time and the effort to implement. So those are also the sort of things that you kind of want to be looking at and saying, how can we leverage certain things to maybe get to market quicker, even if we say that it won't be the final resting place for some of these services, and maybe some of them will need to be enhanced or changed in time. So that should lead to things like quicker development cycles, improving things, looking at other stuff that you can integrate, and all that sort of stuff. AI and ML integration, there's obviously so much movement on the machine learning side and all that sort of stuff. Hugging Face, all of these things have a lot of workloads that can take your data, analyze it, help you with things. And a lot of them come out with prepackaged containers that you can just plug in and point to the data. So there's a lot of things around the AI space that we won't get too involved in. And then just, leveraging multi-stage builds so that you really can push through your dev and your QA in a consistent manner. There's a lot of ways to really improve the things. And then just constantly training and upskilling, just recognizing that, containers is changing over time. People are coming up with better ways to manage, report back on it, and just kind of understanding what other people are doing. Read up case studies. What is this crowd doing, or how's that worked? Are there benefits? Is there a cost reduction now on something like Fargate that makes it a bit more attractive than it was a year or two back? Things like that.
Right. Thank you so much. And we are always grateful to have you with us. I really don't know. I'm just excited to learn more about containerization. And it was lovely to see you, Zippy. I know you're an alumni, and then you've come here today and you are speaking to people who are currently in the program as well. It's good to have you with us. Thank you very much. And if in the absence of any more questions or comments, I think we can end, and I'll reach out via email, Gareth. Thank you
Perfect.
very much.
Thank you so much. Thanks, everyone.
Thank you.